Welcome back, students, to this class of refrigeration and air conditioning. Today we'll start our chapter number 3, that is vapor absorption refrigeration system. So in this section, uh, first we will discuss about the simple vapor absorption refrigeration system and its working principle. So students, you can see here in the picture the block diagram of a simple vapor absorption refrigeration system. So what is the basic difference between vapor compression and vapor absorption refrigeration system? So if I will recall you the components, the basic main components used in the vapor compression refrigeration system, that are first one is your evaporator, then compressor, condenser and expansion valve. Okay, means the only mechanical device that are used in the vapor compression system, that is your compressor. But in vapor absorption refrigeration system, the only compressor is replaced by four devices, that is generator, pressure reducing valve, absorber and pump. And all the previous three components are same, that is same evaporator, same condenser and expansion valve. Okay, only compressor is replaced by generator, pump and absorber. Okay, so you can see the diagram here. It is a, here this one is your evaporator, where heat is absorbed, and let the heat absorbed is QE. Okay, and here it is your condenser. Okay, so uh, and students, it is also called as your aqua ammonia vapor absorption refrigeration system. Okay, so what happens here, uh, in the vapor absorption refrigeration system, the compressor is replaced by absorber. Compressor is replaced by this one, absorber, a pump, a generator and a pressure reducing valve. Okay, so this compressor is replaced by these four parts. Okay, so these components in vapor absorption system perform the same function as that of a compressor in a vapor compression system. Okay, uh, the other components of the system are, as I have already told you, that are condenser, receiver, tank, expansion valve and evaporator. Okay, so this is your expansion valve, this is your receiver tank. Okay, so it is also known as your aqua ammonia, means NH3 vapor absorption refrigeration system. Okay, so uh, in this system, the low pressure ammonia vapor leaving the evaporator enters to the absorber. So you can see here, so this is the point number 1, where the this is the point number 1 where the low pressure ammonia vapor leaving the evaporator and it is entering to the absorber, where it is absorbed by the water. Means water is the absorber and ammonia is the absorbent. Okay, okay students, so it Okay, fine. So in this system, the low pressure ammonia vapor leaving the evaporator enters the absorber, where it is absorbed by the cold water. Okay, and the water has the ability to absorb a very large quantity of ammonia vapor, and the solution thus formed is called your what? Aqua ammonia solution. Okay, so this solution is your strong solution. Okay, this solution means at point number 2 you are getting the solution, that is strong solution, that is aqua ammonia solution. Okay, fine. And the absorption of ammonia vapor in water, it lowers the pressure in the absorber, which in turn draws uh, more ammonia vapor from the evaporator, and thus it rises the temperature of the solution. So some form of cooling arrangement is employed in the observer to remove the latent heat of solution evolved here. So students, so this is necessary in order to the absorption capacity of water, in order to maintain the absorption capacity of water, because at higher temperature water absorbs less ammonia. So the strong solution thus formed in the observer is further pumped to the generator by the liquid pump. You can see here the strong solution formed at stage 2, it will be pumped by the pumping work. You are giving external pump work, that is WP or QP whatever, and it is supplied to the generator, and you are getting point number 3. And in generator there is heating coil or steam you can use, and heat is supplied to the generator, that is QG. Okay, so the strong solution mm, of ammonia in the generator is heated by some external source such as gas or steam, and during this heating process the ammonia vapor is driven off the solution at high pressure, leaving behind the hot weak ammonia solution in the generator. Okay, and this weak ammonia solution flows back to the absorber at low pressure after passing through the pressure reducing valve. So look here students in the diagram. So here you are getting the strong solution, and after heated in the generator, the high pressure ammonia vapor goes to the condenser, and the remaining low pressure weak solution is passed to the absorber via pressure reducing valve, means this is 4 to 5. And in stage 6 you are getting the high pressure ammonia vapor, which is going to the what? Condenser. Okay, where heat is rejected to the atmosphere, that is QC. Clear? So this weak ammonia solution flows back to the absorber at low pressure after passing through the pressure reducing valve. Okay, the high pressure ammonia vapor from the generator is condensed in the condenser to a high pressure liquid ammonia. So this liquid ammonia is passed to the expansion valve, and it stores in the receiver tank, and then it goes to the evaporator and your cycle completes. And look here, after getting the high pressure ammonia vapor, it is condensed in the condenser, and it is the ammonia, liquid ammonia will flow back to the receiver tank, and it will go to the expansion device, and it will further enters to the evaporator, and your whole cycle completes. So students, this is called your aqua ammonia vapor absorption refrigeration system, where you have to remember water is the observer and ammonia is the observant. Okay, so in the next class we will deal with the practical. This is actually the theoretical vapor absorption refrigeration system, and in the next upcoming classes, in the next class we will deal about the practical vapor absorption refrigeration system. Okay, thank you.